arch bones suspending. These two are basically old methods for small processor. Large industry, what they do? Electronic stimulation. They're using a voltage going through the head, going through the carcasses. Why they do electronic stimulation? There's 3 reasons. Number 1, speed up glycolysis process. Before the temperature goes down, before the Raga mode started, you speed up glycolysis. Number 2, it's called physical damaging. I won't say the damaging, but they're using this terminology. What that means? The muscle is highly contracted, is that right? So you use this method, they will be physically damaged. They're not damaged, which means become more tender, like you cut it. Number 3, they will be releasing the calcium. Calcium faster release and speed up, or we say increase proteolytic degradation. Degradation of the protein surrounding the Z-line. Why this guy will happen? Because the calcium suddenly comes out. That's why it's contracted a lot. The temperature is lower, the ATP is still there. They released from the sarcomere, sarcoplasmic reticulum, then the meat is completely shrinked. The ATP is still present. Okay? So that's what they do, the electronic stimulation. Okay? Now, the last one. We want to mention briefly about, I'm going to turn this way around because I'm going to using here a little bit. We talk about the muscle here. Each muscle tender. How we make it tender. We can do something for the connective tissue. We need some fat. The adobe fat will break down or have some pressure to the connective tissue. And will be also help. That's called adobe theory. That will be help increase the tenderness because connective tissue is tough. Okay, so last thing we want to spend a little bit of time talk about the connective tissue and the collagen right here on the side. We want to talk briefly, not going to be talk too long. So here we want to talk about something. Connective tissue, I just say CT. Connective tissue is a major support structure of our body. You have a collagen we talk about. You have a blood. That's all called connective tissue for a large concept. Here we only care about is a major component. It's called collagen. Now what is collagen? Collagen is composed by amino acids. Some people say it's a protein. I will say it's a long chain of polypeptides. It's like amino acids. First of all, if you use X-ray diffraction, you will see a collagen is a triple helix. And the generation of this triple helix, they rely on the 3 steps, including the pre-pro collagen processing or treatments. They need to do some of the self-assembling, and finally, they will do a cross-linking. Now, there is a different type of the collagen. I think there is a 12 different type of the collagens there. But for muscle, the more important is collagen number 1, number 3, number 5, number 7. If I remember, there's number 4 there. Then the 5. Collagen type 1, this is basically is the main components. Collagen number 2, this is we call it's a fine fibril. And all these others, we call it a micro fibril. So basically, when we talk about the muscle collagen, we are talking about this collagen type 1. Now, the collagen type 1, there is a 2 major helix. One is called alpha 1, 2 is called alpha 2. Now, both of these looks like there's separated into 3 structure, which is N-terminal, C-terminal, and a center. Basically, the center composed by 95%. This is a triple helix. So the triple helix basically is in the center. Now, what are going to be the major amino acid components or amino acid sequence of a collagen? Basically, the glycine, proline, hydroxyproline, and the glycine again. And then I want to mention is that for collagen, they could be shrinked when you heat it. So they have a temperature for the shrinkage. So that's called the temperature of shrink. This temperature for shrink is very variable between different food products. A fish product, the temperature for shrink is only 35 degrees Celsius. In a beef, it is about 60 to 70 degrees Celsius. Now, if there's a product, the collagen, you heat it to 80 degrees Celsius, what's going to happen? Collagen is not dissolved in the water. When you heat it to 80 degrees Celsius, it looks like it dissolved in the water. Why? Because the gelatin generates. Now, what is the amino acid sequence of gelatin? Glycine, proline, and hydroxyproline. So simple. What it looks like? Do you still remember what is proline looks like? Since we are talking about chemistry. And I said proline, basically there is no side chain, it's a circle. What is hydroxyproline? One on the top. Okay? That's easily to forming ester bonds if with other chemicals. So glycine is the easiest one. It's just replace all with H is glycine. So that's a gelatin. Now, if we want to talk about gelatin, there is 3 types of the gelatins. We talk about from chemical standpoint: alpha, beta, and gamma. Now, what is alpha? Molecular weight, molecular size, somewhere 85 to 120,000. How about beta? 160 to 150. How about gamma? That is approximately 275 to 350,000. That's from the molecular weight. From the commercial standpoint, we have 2 different types of gelatin. Type 1 is pre-acid treatment. Type 2 is pre-lime treatment. That means alkaline treatment. Now, what's the difference between these? Of course, when you going through so-called kind of like a emulsification process, it will be different. But what it's going to be looks like, the viscosity will be different. Will be different, looks like these two. So that's gelatin. Now, what's a gelatin for? Basically said very simple. It is a soluble protein from an insoluble and insoluble protein. What is that insoluble protein? It's collagen. That soluble protein is gelatin. Okay? Now, gelatin, of course, you put in the cold water, what happened? It was swelling. It was swelling a lot. When say in a cold water, it will happen is swelling. Now, from chemistry standpoint, from structure standpoint, what's going to happen? Red coil become alpha helix. How they connected with each other? A very weak hydrogen bonds. Okay? So these are the things. What I draw on the blackboard is all this basic knowledge you should know before we talk about slides on Thursday. There is a very important another thing we want to mention is that there is some of the animals, especially pork, there is a genetic dependence. They have some of the genetic mutations will cause the mutagens of the calcium. The sarcolemmic reticulum, the calcium release will be different. If that one is not controlled very well, what happens? The meat products will be completely awful. So, if you want to do a conclusion here, we want to talk about here, regarding tenderization, what do you have to do? Look, this structure, active myosin, you cannot change it. But you should make sure it's not overdue. Is that right? If it's already tough, don't make sure it's become too tough. These things we definitely can work surrounded the Z-line. Those proteins we absolutely can work on. And the last thing, we need some fat of the beef products. So therefore we have a grass feeding and forage feeding or different type of the feeds there. Because when you have a feeds there, the fatty acids will be different and they're going to have some impact for the connective tissue. Because the connective tissue is very tough unless you cook it. Become a gelatin. So these are the key things. In the industry they work a lot, and of course for large industry, the electronic stimulation is key. Now for the small processors, the very important thing is this cold shot. Okay? Okay, the last thing before we end, I want to mention the one we talk about is a muscle structure. So we go back, want to give you a conclusion. What are going to be the muscle looks like? What will be the components of the muscle? So a muscle protein. There is 70% of a muscle protein is we call it a structure muscle, a structure protein. 30% is water-soluble protein, which means they can dissolve in the water. Only 30%. Myelin is one of them. Another one, myoglobin. Now, what are the 70% structure protein of a muscle? This is we already talked. 38% is myosin. 17% is actin. There is around 13% is tropomyosin. Remember there, triple myosin. There is another last 7%. Is stroma protein. So at the end of the day, we go back to talk about the muscle proteins. That's their components. Here, we don't worry about these two. We care about is on the top. Because that cross link is paying much more attention. This water soluble, you dissolve in the water, it's gone. That's a reason, okay? So, here, now I want to also mention in your anatomy class or the animal science class, you learned about here a little bit, is that right? Did you learn the contraction, releasing of the muscle, relaxing of the muscle in any of the biology class?
No.
You learned a little bit right here. Is that right? So what's the story? If you have a contraction, neurotransmitter is acetylcholine, gonna tell you need to contract it. So what do you do? This large F acting, the tropomyosin will twist it. So the troponin will be present to the calcium. Will accept the calcium. Then what happens? The troponin will be present. The actin go to the myosin. So the actin myosin cross bridge will be there. Once it's relaxing, what's going to happen? The calcium will release because the tropomyosin twisted on the other way. And then the ATP will have to generate. Then they have to become a relaxing. At the same time, that neurotransmitter, the acetylcholine have to be hydrolyzed using chlorine esterase. Chlorine and esterase. Okay, so these are the things you should learn in your anatomy class and the other classes, so we just don't mention too much here. But the structure is right here. And I remember, if you have to teach that class, you're going to have one step, second step, third step. This half page, we talk about the relaxing. The other page, we talk about the contraction. And this is completely opposite.
Is that why they say that people that have like heart problems, sometimes they take choline supplements
Yes.
to help?
Choline supplements, they can add it there. That's, but they're manually added.
Yeah.
We'll talk about, there's a chemical, that's chemical treatments, which is post-harvest. But there's lots of things we talk about pre-harvest. So we'll mention about it in the slides. That's why when you see the slides, there's lots of information. And these are the basic knowledge you should know before you talk about that. You know. Okay.